Okay, guys, so here we are at the table of truth and knowledge. There's an inside joke there for some of you. And I had someone ask me if I had any piping to show and tell, and not so oddly, I do. So here it is. I have a couple of coupons of piping that, not so oddly, I have collected over the years. Those people who know me know I'm a collector. Remember, if it's useful, especially in the education of others and the furthering of the profession, it's not hoarding, it's storage. That's why I don't have very much of it, and I still probably have more than most. What we're seeing here is a piece of 3-inch pipe with a 2-inch Schedule 150 flange. No surprise, right? Nothing fancy. Let's talk about what makes this so unusual and why people may be interested in it. It is a piece of 3-inch pipe. The thing that you'll notice rather quickly is, see if I can get this to stand up, is there is a significant difference between the wall thickness from one side and the other. How significant? Significant enough that it has a hole in it. And when I mean a hole, I mean through wall corrosion, or complete wall loss, as some people like to say. This was a piece of pipe that was in standard petrochem service, and it was identified as being suspect, and when it was inspected, it was in fact thin. So much so that at this injection point, this right here being a injection point, right here in the downstream side. And what's interesting is, even in the upstream side, corrosion was going on, but in the downstream side, it created a complete through wall thing of corrosion. Interesting service. Can't talk about the location. Here's another one that I've collected from things over the years, and you notice a lot more holes, not a Schedule 150 flange. It is a standard carbon steel, SA 105, extra heavy. Nothing too fancy about this one. Once again, this is an interesting spot where it was a flanged T. You notice flange, magical T. And through the magic of large bandsaws, I had this one bandsawed apart because it also, with Schedule 80 piping, and this is why I'm a big fan of Schedule 80 2-inch piping as a minimum. Almost full thickness. And then on the other side, you see it is significantly thinner. Notice, because it was stress relieved, though, the welds are approximately the same corrosion rate as the base metal of the fitting and the flanges, right? That's significant. This is probably a really good advertisement for post-weld heat treatment. A stress relieving, as a lot of people in the industry like to colloquially refer to it as. Notice here, though, let's see if I can, yeah, right there. Complete through-wall corrosion. This was identified, and between the time it was identified and the time it was actually removed, it actually began to leak right there. That hole right there. Once again, interesting example of corrosion in a typical refinery application. This one was HF service, hydrofluoric, one of the funnest acids on the planet, only acid on the planet known to etch glass, and we use it in hydrocarbon service. This is one of my favorite pieces in that it actually has indications of the fluorides, the fluoride colors. Obviously, it's been neutralized, so so it's safe to handle. Yeah, not a big, not a big fan. Here's another example that I did to show what happens when you get corrosion based on too much and too little of a weld. That would be a prime example of too much, and because of that, it's getting erosion. In this case, it's not corrosion, but erosion, where there was either a line of non-fusion or undercut, internal undercut, at the edge of the bead. And look how heavy that bead is. The interesting thing is this weld and all the welds on the circuit were 100% RT'd. So one would ask, why did that pass X-ray? Well, that would be an interesting conversation, but that would be a whole nother tangent for a conversation. But anyway, here's a bead that was probably right at level, and you notice there is some preferential erosion, corrosion going on. Here's another interesting thing. See these little, what look like pock marks? The tight pin type pitting examples. That's from hot hydrogen. Hot, dirty hydrogen. Obviously the hydrogen wouldn't be doing it, but the hot contaminant in the hydrogen service was the culprit. In that same, well, not the same service, but in the same process, here's an example of a piece of Schedule 80 2-inch standard wall thickness. And on the other side of a 90, this is a 90 that's been cut from extrados to intrados across the cord line. And the reason I had it cut like this is because this is the corrosion I wanted to show. Notice that there are linear striations. I say notice that. I don't know how many people would see that as linear. And it might be the limitation of how I'm trying to film it. Let's see if I can get that as an angle. But notice that they're linear and they're aligned in, you might even be able to see them in the bore line of the pipe. If I could hold this still enough. You see those lines. Those aren't just figments of your imagination, though. Those are actually lines where they're lines from where the contaminant in the hydrogen stream was flowing against the piping. Let's see if I get some light in there. More light. And because of that, it was impinging on the back of the 90, the extrados, right? That's the technical and correct term, code term for that. The outside line of a fitting is the extrados, and the internal side is the intrados. Not the inside and the outside, but the intrados. Anyway, nearly through-wall corrosion, erosion on a Schedule 80 2-inch. One of my favorite pieces. At one time, I actually had a whole collection from this same circuit that included some 1-inch socket welds and some 1-inch gate valves, both gate and plug valves. And they all had these indications like this, where because of the contaminants in the dirty hydrogen, were actually physically eating out the metal in both erosion and corrosion. But like so many things, when I changed employments one time, they decided it was their personal property instead of mine, even though I'd got it out of the dumpster. Yeah, you know how it works. Anyway, here's some other examples of wonderful corrosion. This is at a heat affected zone. It's at the bottom of a socket or a weld outlet. The heat affected zone. I don't think it was stress relieved. They said it was. I'm thinking this is a perfect example of proof that it either wasn't stress relieved or it wasn't stress relieved properly. Preferential corrosion. I mean, there is some wall loss on the pipe. I say some, a significant amount. Let's see how thin it is on this side. Now, this was Schedule 80 when it started. But I think it's interesting that the heat-affected zone sure seems to be affected at a significantly higher rate. Anyway, that's just some show and tell here at the table of truth and knowledge. Anyway, hope you guys enjoyed that. Thanks. Bye.